Okay, so today we're looking at what does it look like when we model integer subtraction. So when I look at these notes, so the main difference that I noticed from these notes to my addition notes is that my addition notes had two different representations. They had a number line and they had tiles. But when we look at integer subtraction, the only type of pictorial representation, which just means showing it as a picture, that I have for subtraction, it's just a number line as an option. So we're going to start with a few just kind of basic problems, and we're going to see if we can find a pattern. So my very first subtraction expression is just 3 minus 1. Well, 3 minus 1 is a problem that y'all have been doing since kindergarten when we first learned to take away things and all of that stuff. So what I notice about this problem is I have a big number minus a small number, okay? This problem is totally okay to do. So I can do 3 minus 1, which would give me a value of 2. So for my number line, I'm going to start here at 0. I'm going to move 3 spaces to the right because it's a positive 3. And then I'm going to take 1 away, which is like going 1 to the left. And sure enough, I end up there at 2. My next one is 3 minus 2. So again, I have 3 things. I'm taking 2 of them away, which would give me a value of 1. I'm going to start here at 0, move to the right 3 spaces, and then move to the left 2 spaces. And sure enough, I end up at positive 1. I have 3 things, and I take 3 things away, which would give me a value of 0. So I'm going to start here at 0, move to the right 3 spaces, and then take 3 spaces away. So I end up back here at 0. So all of these problems are totally okay. We know how to subtract a big number minus a smaller number. But then I end up with problems like this, 3 minus 4, where I'm trying to take away more things than what I have. So I could read this problem as I have 3 apples and you take 4 of them away. Well, that problem's not possible. I can't take 4 things away if I only have 3 of them. So in order to do a problem that looks like this, where I have a positive number minus an even bigger positive number, is I want to change this expression into an addition expression. And I do that by using 3 letters. Those 3 letters are L, C, O. They stand for leave, change, opposite. So I'm going to leave that positive 3 alone. So it's going to stay 3. I'm going to change that subtraction to be an addition. And then the opposite of positive 4 would be negative 4. So if I change this to be 3 plus negative 4, I can go back to my integer rules where we talk about if they're the same signs or different signs. So here I notice I have a positive and a negative. They are different signs. So when my signs are different, I subtract and I keep the sign with the most. So if I subtract 4 minus 3 would give me 1, and my sign with the most is negative. So I get negative 1. And I can use my number line to prove this. I have a positive 3, so I'm going to start at 0, move to the right 3 spaces, and then stop. And then since it's a negative 4, I move to the left 4 spaces. So there's 1, 2, 3, 4. And sure enough, I end up at negative 1. So when I look at number 5, I see 3 minus 5. And again, I'm like, I can't take away 5 things if I only have 3 of them. So I need to change it to an addition expression. So again, my 3 letters that help me do that are L, C, O. So I'm going to leave the 3, change the subtraction to be addition, and then the opposite of positive 5 would be negative 5. So I see that I have different signs, so I subtract and keep the sign with the most. So 5 minus 3 would give me 2. The sign with the most is negative, so I get negative 2. And let's prove it with our number line. I'm going to start here at 0, move to the right 3 spaces, stop, and then I'm going to move back to the left 5 spaces. So there's 1, 2, 3, 4, 5. Sure enough, I end up at negative 2. Okay, let's look at set 2. So the first thing, y'all, when I look at set 2 is I think those problems look so ugly. Look at all of those negatives and subtraction symbols all over the place. Okay, so I know right off the bat, when I have all of these negatives going around, especially when I am subtracting a negative number, I don't even want to try and mess with this. I just want to go ahead and turn it into an addition expression. Let's go back to those rules that we know how to do. So I'm going to go ahead and do LCO. So leave it, change it, opposite. So I'm going to leave it as negative 3. I'm going to change this to be a positive, or excuse me, a plus sign. Sorry about that, a plus sign. And then the opposite of -1 is +1. So I have -3 plus 1. My signs are different, so I'm going to subtract and keep the sign with the most. So 3 minus 1 would give me 2. The sign with the most is negative. So I have a value here of -2. And we can use our number line to prove it. So I'm going to start at 0. But this time, since it's a -3, I'm going to move to the left 3 spaces. And then a +1 tells me to move to the right 1 space. So I end up with -2. -3 minus -2. Again, subtracting that negative, that is ugly. So let's change it using LCO. So I'm going to leave it as -3, change the subtraction to be addition, and then the opposite of -2 is +2. So I have -3 plus 2. I have different signs, so I'm going to subtract and keep the sign with the most. So subtracting would give me 1. Sign with the most is negative. So I'm going to start at 0. I'm going to work my way to the left 3 spaces, and then work my way to the right 2 spaces. So I get -1. -3 minus -3, again, that looks ugly, so let's fix it with LCO. So I have -3 plus, and then the opposite of -3 would be +3. So I have the same amount of negatives and positives. Remember, that's what creates what we call our 0 pairs. So the value of this would be 0. So I'm going to start at 0, move to the left 3 spaces, move to the right 3 spaces, and I end up at 0. Okay, I'm going to just keep going so that way we can get to some problems on the back. So -3 minus -4, LCO would be -3 plus +4. Different signs, so I subtract and keep the sign with the most. 4 minus 3 gives me 1, but this time my positives have the most, so it's +1. For my number line, go to the left 3 spaces, right 4 spaces, and I end up at -1. Last but not least, -3 minus -5. Let's go ahead and do LCO. So it becomes -3 plus 5. Different signs, so I subtract and keep the sign with the most for a value of 2. My number line, start, and I go to the left 3 spaces, the right 5 spaces. So I end up with +2. So let's look at 3 problems on the back. Okay, so I have -6 minus 2. Since I see a negative sign with that subtraction symbol, I'm going to go ahead and do LCO. So again, I'm going to leave it as -6. I'm going to change the subtraction to be addition, and then the opposite of +2 would be -2. So when I look at this, I see that I have the same signs. They're both negative. So when they're the same signs, all I do is I add and keep the sign. So 6 plus 2 would give me 8. My sign, since I keep it, stays negative. So this has a value of -8. So I'm going to start at 0, work my way to the left 6 spaces and stop, and then work my way to the left 2 more spaces for a value of -8. 3 minus -4, again, that subtracting a negative is ugly. So we're going to change it using LCO. So I'm going to leave it, change it, and then the opposite of -4 is +4. Now this is just a beautiful, nice problem of 3 plus 4, which gives me 7. We love adding just those positive numbers. 1, 2, 3. 1, 2, 3, 4. Ooh, I think I went too far. There we go. All right, last but not least, I have -2 minus -1, negatives and subtractions all over the place. So let's fix it with LCO. I have -2 plus the opposite of -1 is +1. Different signs. So I subtract and keep the sign with the most for a value of -1. So I'm going to start and go to the left 2 spaces and the right 1 space.